All right, our lesson is 10.1c. And 10.1c is the area of an actual piece of a circle. So this piece of a circle is going to have like a curvy edge, fully like a piece of cake or a piece of pizza. I want to know the area of that whole triangular shape, right? And since it has a curved edge, I really care about what is that central angle. What's the angle measurement that creates this piece of the circle? So find areas of sectors. Our students will be able to, our goal is that we're going to find areas of sectors and segments. And I'll show you what a segment is over here. So a sector is this little pie-shaped shaded region. A section, and I'm going to say bounded by. That means like the boundary line, the beginning and end, bounded by 2 radii, right? And then obviously it's the edge of the circle is the other edge. Easy. Okay, but then the area of this segment. So this is my 2 radius. Then I drew a line. Now there's a line that is called a chord, C-H-O-R-D. And a chord goes from one endpoint to another. It does not cross the center of the circle. So this line is my chord. So I have my radius here. I'm just going to put R for radius. I don't need to go full on word. There's my radius and there's my radius. This is called a chord, this C, because it is just a little piece. So what I'm really looking for is this moon-shaped section right here. That's an enlarged version. That's what I want the area of, just that little piece right there, okay? So how this is done. I first need to find the entire pie-shaped piece. We're gonna call that the area of the sector. Capital A means area, and I'm gonna put the word sector down here because I have to do the entire triangle. And then I am going to subtract out just this triangle, the area of the triangle that's created. And I don't know how many degrees my triangle is, so I can't necessarily do 1/2 base times height. I'm going to do this formula. We used this formula last chapter, and it would be like the radius times the radius sine of the angle. That's the formula. It's really like B times C times sine of A. But since the radius are the same size, I think it's fine if we just go R times R. So this is going to happen later on. Actually, it's when we flip over to the back side. But I at least want you to know that we're finding area of a triangle, not the traditional 1/2 base times height method. The formula. Yeah.
Oh, does that say a section bounded by 2 radii? Sorry, I can't really see. There's a glare on the board.
Yes, I know there's this glare. Yes. Bounded by 2 radii. The 2 radiuses. Okay, we know that area of a circle is pi r squared, right? Well, I need to multiply pi r squared times whatever degrees this angle creates, like I have this shape, I have this pie shape. And I need to know how big that pie shape is. So that requires me to go, if the area of the sector, AS, this stands for area of the sector, relates to pi r squared, obviously this is a circle, they do. The degrees of my angle divided by 360 degrees, obviously these relate because they're both degrees. So this is the proportion that I would write. But if I want to just isolate area of the sector, I'm going to multiply and move the pi r squared over to the right so that I have only, and here it is, handwritten, area of the sector. The sector is this pie-shaped, right? La, 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 la. Whatever degrees the angle is divided by 360 times pi r squared. So I need to know the radius and I need to know the degrees of this opening, of this angle. This is it. This is the key today of what we're doing. Very similar to last lesson when I just said, well, find the circumference or find the area, find the length of a segment, a length of the curving circle. So first we're going to spend, 4 examples doing area of sectors. 1 and 2, I am given the radius and I am given the angle measure. So you can see that this says 11 meters and 135 degrees. So using the formula above, I'm going to do degrees, 135 divided by 360 times the formula for area of a circle. Pi times 11 squared. Now this AS means area of the sector. So your calculator now, this is on you. Whatever way you want to enter it in, depending on the version of your calculator, right? So straight across, straight through, do it. And then I need an answer. So get comfortable with your calculator, practice it. Let's see if you get the correct answer. Okay. Someone tell me, what is it?
I got 142.5.
That is correct. 142.5 meters, 11 meters squared. I found area of something, it has a squared notation because it's two-dimensional. Okay, all your calculators got this. You all achieved this? Okay. So unshaded, this is like, okay, think 2 steps before you actually start solving this problem. The unshaded region is 80 degrees. But the shaded area is what I need to find. So I hope you got this, but someone tell me, what are you going to say? Oh, yes, because you did 360, take away the unshaded portion. My angle, that giant angle, is 280 degrees. 280 divided by 360 times pi 4 squared. Pi r squared, pi 4 squared. Okay. Pi times 280 divided by 360 times pi times 16, right? I mean, this is fine. 0.7778 times 16 pi. The area of the sector is what is it? New people on Zoom. What'd you get on your calculator? You're all doing it, yes?
39.1.
Excellent. 39.1 feet squared. Okay, I was given the angle, I was given the radius. Next problems, 3 and 4, I'm going to be given the answer, basically. I'm going to be given the area of the sector. So I'm scrolling down. So instead of AS, I'm actually going to write what I'm given. The area of a sector is 35. Find the radius. Degrees over 360 times pi. I don't know what radiuses are squared. So R is my variable to solve for. So I can do like 100 divided by 36 times pi. Let's isolate R squared. Basically, 100 divided by 360 times pi is 0.8727. Yes? Agreed, agreed. 100 divided by 360 times pi. Okay. Okay. Isolated. R squared is 40.1. I mean, it's long, whatever. There's a lot. You guys keep it in your calculator long, because then you get the precise answer when you keep all the digits. You want to do that. Square root both sides, yes? R equals, did you get 6.3 meters is my radius? That's how long my radius is. All right, so that was a simple, okay, just find the radius when the radius is missing. Now it's asking me, find the circumference, which you know is 2 times pi times radius. But I still have to do all my work. What I mean is, I still have to do. The area of the sector was given to me. Great, 220. Equals, because I need to find the radius, and then I can use the circumference formula. So first I need to find the radius, and then I can plug the radius into 2 pi r. Yeah? Okay. The degree, oh, degrees, it doesn't say. Unshaded is 90. Unshaded is 90, which means shaded, hopefully you can do it, no problem. What is it? Did you guys all get 270 on your calculators at home? You guys? Please. 270 divided by 360 times pi, I don't know, r squared. Very similar to the last problem. Very similar. And go, go, go. Okay. Square root both sides, right? Are we on the right track? Are you getting the numbers I'm getting? Square root of 93, well, obviously it's gonna, square root of 100 is 10, so it's gonna be less than 10. Someone on Zoom, tell me what you got, please. Sure, round it to 9.7. 9.6, 9.7, it's all good. Okay, that's my radius. Then, circumference equals 2 times pi times 9.7. Go. 2 times pi times 9.7. $60.7, you guys, approximately? Yes, yes? So I had to find the radius first, 9.7. Plug that in to the circumference formula, 2 times pi times radius. Got the circumference of the whole circle. Okay. We're doing good on time. Great, great, great. Now we get to go into the segment. Of course, remember the segment kind of looks like that moon shaped. And the big idea is that I have to find the area of the whole sector and subtract. So find the area of the entire sector, and then I'm going to subtract the little triangle, then we have to find the area of the triangle. Okay. So it's area of the sector. Take away area of the triangle that's made, gives you the area of, like, I'll just do like the moon shape. We call that a segment. So calculators are still needed, friends. Keep it out. All right. I know that the radius is 10. Oh, it's a box. It's a perpendicular. That's a 90-degree angle, correct? Okay. First I find the area of the sector. 90 over 360 times pi 10 squared. Okay, go ahead. Ninety divided by 360 on your calculator. All right, what's the answer? Someone on Zoom.
78.5.
Thank you. Feet squared. Okay, let's talk about this area of the triangle. I told you the formula on the front side. This triangle has whatever size angle. We got lucky. This is 90 degrees. I'm still going to do 1/2, one of the sides, and the angle in the middle. This is from last chapter. Just so happens that it's going to end up being 50 times the sine of 90. So put that in your calculator. 50 times the sine of 90. What you get? $50, because guess what? The sine of 90 is 1. So the area of the segment, or sector, well, man, segment was last, is 78.5. Minus the area of the triangle. Sorry, I'm blocking the triangle, but the triangle is 50. I still have to use the unit of measure squared. Feet squared. Feet squared. And yes, we have time for the next. Okay, ready? The angle measurement of this giant piece is 144. The radius is 5. Same. Area of the whole triangular slice minus just that white triangle taken out. This triangle right here, which has a 144 degree measure, and it's 5 and 5 on each side. I would actually like right now to write the whole thing out with a subtraction problem in it. So it's the area of the sector minus the area of the triangle. So 144 divided by 360 times pi 5 squared minus 1/2 5 5. It's always sine of 144. I don't know if your calculator can do that much. You might have to do the left side and then the right side and then subtract. Try it. I don't know, man. Try it. Make sure you get what I get. Okay. Did you get 24, about 24, 24.1? Meters squared. All right. So you can start on the homework. The homework is below. It's the 7 problems below that you see. Just 7 problems, okay? All right, go to it, get started on that.
Miss Grant, for number 6, would it just be 360?
Number 6.
Yes.
Yeah, the whole thing is shaded. And because that's just the whole circle. Like just find the area of a circle. So it's super simple, like 6th grade math problem.